Hi everyone, welcome to this session. I'm going to discuss about the skewness on even data distribution across the partitions. This is really important topic and very common problem within big data processing after shuffling. So that's the thing, after shuffling. So there are lots of shuffling techniques at transformation scale. So as we call group by key, let's say sort by key, join, and a few more, right? These are the shuffling techniques. So we must be very careful to keep data running and also keep Spark running over data in the pipeline seamlessly because the topic is in parallel processing. So we have to keep this in parallel, from the beginning to end of the processing. So when we talk about shuffling is going to create usually the combination of keys and values, right? So the problem is usually when the key distribution is not uniform and is called highly skewed, like this, these partitions. So what is the reason? The reason is the original data is skewed, means I mean, there are not really uniform data, and that's the reason we call it highly skewed. So let's say we have data that we want to discuss, we want to consider, what sort of data we need to create this skewness. So data now is ready in Spark. Spark has been divided data into let's say four partitions. And then after that, you want to run a group by key transformation on data. After, this shuffling, you would get, these four partitions. And one partition keeps, information about key 1 and key 5. Second partition, small partition, but third partition is really big partition, key 3 and key 5. And key 4, the last partition. So here we have lots of data in these partitions, and this is really a problem. It's going to overload computational resources, and we want to discuss it. So let's say you want to apply, let's say, map transformation over this, data. So once you want to run mapping is going to run in parallel, right? So let's say now we are here. So once you are here means K2, this partition 2 and partition 4 have been done. Means they are done, and the cores for this one and another core for that one, they must be, free. But since there are still these two partitions under processing in parallel, means these two cores should be idle, for a time, let's say for a short time, let's say for a time being or for a long time, depends on, the processing of these two partitions. So these are idle, this one and this one, the cores associated to these two partitions. Then now we are here. We are here is done. Now we have one core, two cores, three cores, free of doing any job. But they must be idle. We cannot send them back to the, to the operating system to say, okay, operating system, we have done with these cores. Now you can use these cores. These are free cores. You can't do that because they should wait for this partition to be done. So as you can see from here till the end of the process, we have three cores, unused three cores, and this is really bad core management, and it's going to take lots of time. Also, it doesn't, it's not going to be run in parallel because since the huge part of data is going to be here, it means it's going to run, running with one single CPU, and from here to here we have the concept of in parallel, right? Till here means from start to the end we have this concept of in parallel because 1, 2, 3, 4 processing are running in parallel. But from here, let's say once it's finished till the end, we have only one, partition is going to be run, but is exactly, out of in parallel concept. So we have to find a way to distribute these keys, to distribute these data, in particular in this partition tree across other partitions to have them, uniformly distributed, and then we can speed up the processing. Also, we can keep, computational resources, at the safe mode. In this case, we can say that we had, really nice optimization over computational resources. So how to do so? There is a technique we call salting. So salting is a technique that's going to add random values to the join keys. So as you can see, we are working with keys, and then Spark can partition data evenly. So what does it mean? It means this third partition, we have to, break it down into, several partitions and distribute it across the partitions. And then, as you can see here, we can run 1, 2, 3, 4, 5. So let's say now we have 5 partitions that we need to take advantage of 5 cores, and then we can run them in parallel, right? And then the minute that, I mean, the concept of in parallel is happening here. So this is the idea of skewness that we need to uh, take into consideration, the challenges and the solution as well. This is really important, challenge of distributed processing. So let's take some examples together to be able to understand this topic. So let me take you here into VMware machine. Since we have to monitor Spark user interface and Spark engines. In this case, you need to work with this, Ubuntu machine. So as you know that this Ubuntu machine, the password is big data admin. So big data B and D are capital letters, and the rest are lower cases. So, and